The demo portal is intended at a very high level to converge data from multiple domains throughout the customer's network and show them all in a single pane of glass. So what you'll see through this portal as we glance through it are views from a couple different sites. So our internal operations, our ITSM platform service now drives incident problem change, drives asset management, drives rollouts for the customer network. That'll all be represented here. The customer network telemetry from the network management platforms from an SD-WAN perspective, managed access, managed switching, LTE, all of our secondary network services are all represented here. So as a customer, rather than going into 2, 3, 4 different portals throughout my network and trying to correlate data between these rapidly, I can see a single pane of glass for everything that's happening in my network, both from an operational and from a network standpoint. Furthermore, as we'll see when we get into it, we can see views of the QoS platform or the Zayo platform that drives a lot of this network observability. So you'll see our AIOps and our alerting platform highlighted here, and you'll see the operational takeoffs from that. As we look into this, a couple things that you'll notice from a very, very high level is when the customer first logs in, we draw their eye right to current, immediately ongoing issues. So this map view, here we show the United States. It's a global map view of any current issues in the network requiring customer attention. So this is typically something where we have an issue in the field. We've attempted to reach out and solve it. We are missing access or missing information from the customer. We're on hold because we can't do anything else. We need information from the customer. Similarly, any critical issues, so any priority 1 issues that are affecting multiple sites or 10% of the network will be surfaced on the map here. So for example, if there are critical multi-site outages due to a network event, let's say a regional carrier outage, or due to, let's say, a weather event will show up on this map. Again, the goal is to drive the customer towards what we need from them from an operational perspective to most quickly remediate some of the more critical issues in the network. A couple other things at a high level when we start looking at the portal as a whole. Few things that we can look at from a navigational and from an overall portal structure perspective. The site does have a light and dark theme, so customers that are interested in either, light theme is at the default. We typically leave it on dark theme because it showcases a little bit of the nice dark design, gives a little bit more of a technology feel. Both of those views are available to the customer at any given time. Additionally, we have the ability to create a new case or ask a question of our network team, our CSAT team at any time. Those cases are today SSO into our ITSM portal. It allows the customer to report a network issue. It allows them to request a service change or request a configuration change, as well as contact our teams to administer their account. Some of the functionality behind that new case system is going to be migrating onto the portal as part of a v1.1 coming up here in Q4. We're going to allow customers to have a lot more network management features directly within the portal. Today, we do have that. There's in a legacy portal. As an internal note, we want to try to not highlight that as much, but the ability to do that is here. Next thing going down as we look at the rest of the overview for the portal, we're drawing again the customer's attention to currently open incidents so that they can go down and start looking through their incidents. We'll see a detailed view of that here in a moment. We draw their eye to sites with risk. Sites with risk we define as anything with an open alert or an incident less than priority 2. So that's something that is affecting the site that is not currently causing degradation of the site. Good example of that is if you're at an edge location with a broadband and an LTE access, and the LTE access is unavailable. Well, the broadband is still up and running, the customer is still up and functional, but we're representing this as risk because we have a loss in potential redundancy. Were that broadband link to go down, we wouldn't have LTE available to fail over, and therefore the site would go hard down. So sites with risk for across the entire network is anything where we're noticing alerts and we're noticing things happening, but they don't represent an immediate failure. Further looking at the site, overview here, we can look at both our MTTR, our MTTD, and our SLA attainment. So essentially what this measures is our SLAs for services as our NOC performs services on the network. So represents our initial follow-up to an incident within the system, as well as our response rate within the system. Our target here is typically within the 80+% range. So you can see for different priorities over time, we're doing a pretty good job for some SLAs. For some other ones, they change over time. So the idea is to be able to go over here, look at the SLAs over time, collaborate with our NOC and our technical service managers to understand, are we doing a good job of managing the network? Similarly, when we look at the MTTX statistics, mean time to detect is the average time that it takes for us to receive information about a fault in the network, to get an alert, and that time that it takes us to generate an alert into an incident. Some of those are very, very quick. Some of those are purposefully delayed by a longer time for messy or network sources. So when we look at mean time to detect, it is not encompassing of a single point of failure, but rather all failures within the network. Some things we detect really, really quickly. We have an alert for it. You'll see all the alerts in the system here in a second. Sometimes we take those alerts, we immediately convert them into incidents for our team to work. Sometimes we take those alerts, they live in the system. We wait to see if they are either going to auto-resolve on their own, or if they reoccur and become a flapping issue, we'll immediately turn that into an incident. The system that performs that logic is our AIOps platform that underlies our entire alerting and event management system and provides true observability to the entire platform. Talk more about how alerts are converted here in a second. First, we want to review MTTR, so mean time to repair. We look at mean time to repair across the network. We can see as that trends month over month, week over week. And as we look at mean time to repair and we go down to look at how alerts drive that mean time to repair, you can see kind of those two numbers are playing together. So MTTX plays well with our SLAs as we perform it from an operational perspective, and plays well with what we do from an alerting perspective. So moving down the page and looking directly at alerts, you can see one of the things that's happening here that we're highlighting is from an alert volume perspective, we're taking alerts from multiple different sources into the system. We'll do a source breakdown here in a little bit, but essentially we're gathering data from either webhooks, so push messages from different network sources, from SNMP, traditional polling-based network telemetry, as well as we consume APIs, syslog, and a couple other secondary and tertiary monitoring protocols. Between those several protocols, we then generate events into our AIOps platform for those. Those events, also known as alerts, are classified as either warning or critical, and they are compressed and enriched based on a couple different factors. What happens when an alert comes into the system is that it is tagged with our configuration management database, CMDB in ServiceNow. That CMDB enrichment informs where this device is, what location, what customer, what physical address, how it's configured. So is it configured as an active site, active backup, is it DIA, et cetera. And all of those inform an alert processing engine, which then allows us to correlate different alerts. So what you're seeing here when we look at an alert volume of 9,000 versus an actual incident volume of 2,500, that compression rate is by us taking multiple different information sources, compressing them down into a single actionable incident for the NOC. If you look at the details here on the right of top alerting sites and hosts, you'll see some sites and some hosts with a lot of alerts and a single incident. That's a good example of something where we've compressed 30 alerts down into a single incident. Sometimes you'll also see, you don't see it here, but sometimes you'll also see some alerts, but multiple incidents, where those alerts are strung over a longer amount of time, and we've actually generated multiple incidents for multiple distinct events. Good example of that would be, well, we correlated a bunch of alerts at a site, at a single location. Let's say the broadband, LTE, SD-WAN edge, and network power device all went down at the same time. Pretty evident that we lost multiple devices. We probably have a power issue or some extraneous factor. Let's say weather took down an entire site. Well, what can happen is that some of those alerts can clear. Let's say that we bring back the network power, the SD-WAN edge, and the broadband, but our LTE doesn't come up. We would want to keep that LTE alert open as a separate incident and to work that separately from the main power event. So our AIOps correlation engine has the ability to take those alerts, converge them onto a single incident, allow the ops team to work it, and then split that back out for additional triage once the original incident is worked. Last item on this page that we want to highlight is the alert breakdown by types, by both alerts and incidents. So again, that drives a lot of the MTTX numbers that you see above. So for instance, when you see in this particular example network, most of our alert volume is driven by link failures, significant amount of link failures in both wireless router correlated with backup link down. So we have a lot of LTE wireless router issues, things flapping on and offline. Again, probably due to some regional events. But what we can say is that because of those wireless routers, those represent a loss of redundancy. They don't necessarily loss of degradation in service, which is why you may see some of the prioritization, and you don't see a lot of critical issues in the network, but you may see risk rising in the network. So being able to break those two things out and really intelligently route alerts by the service that has failed, how it has failed, and when it has failed, allows us to intelligently route incidents to our NOC team to help them triage and prioritize the most important issues in the network. We don't want to spend a ton of time chasing ghosts on backup links that are flapping due to carrier maintenance. We don't want to spend a ton of time chasing issues that are not currently affecting users, because we do find that a lot of these incidents and a lot of these alerts do auto-resolve due to factors outside of our control. Next breakdown on this page, starting to look at different incident trends. So as we look at trends in MTTD, MTTR, as well as incident trends, again, here you have a breakout of incidents by priority. So you're going to look for individual spikes over time or individual trends over time, and look for anything anomalous here. So if you look at over a long period of time, we look at decreasing MTTD, decreasing MTTR, no anomalous patterns in our incident trends broken down by priority. Looks like, although there is some noise in this network, it's a very large network. For this reference example, customer is about 1,500 sites with several thousand endpoints. So there's a good amount of noise in here, but as you can see by looking at these trends, by zooming out and looking at the network as a whole, we can say that overall the network is fairly healthy, exhibits a fairly low level of risk, and we're doing a good job of managing it over time. Moving down to the last part of this page, you can always come down here. The customer can see incidents, problems, and tasks that have been assigned to them. They can drill down into those at any time, go see details on that incident, go view comments. They can communicate back and forth with a NOC, add attachments, and really help co-manage to drive to resolution on a given incident, problem, or change. All of these are broken down in a couple different places in the site where you can search and filter. They're available for a quick reference here. Another place of a quick reference where we get a little bit more detail of current issues that are affecting a given network is that we can see a breakdown here. Similar numbers of what we were looking at before, but broken down in a little bit more detail, where we're looking at a given site, looking at a breakdown of, is the SD-WAN edge stable? Do we have a high level of quality on the link? Are both links active? Do we have secondary services? So for example, network power, HA, are those things active? Some of these things are related, and that sometimes if you'll see two links dead and an SD-WAN edge dead, that indicates probably we had a connectivity outage that brought down the entire site. Sometimes you'll see perhaps the SD-WAN edge is lost, but the network link is up. So we're monitoring it. We see that WAN access is good, but we haven't had an SD-WAN issue downstream. So this enables us to roll up multiple issue types into one single view. We allow the customer to be able to sort, filter through this, and then download this data if they need to. They can always go through and look. Oops. Brief reset. Well, I found the bug. Okay. Going to briefly start over here and start talking about the site breakdown. Allows customers to sort and filter and download data on a per site basis, allows them to understand which sites are utilizing the most bandwidth, which sites are the most stable from a quality of experience standpoint. That QoE score is represented by the WAN access quality, comprised of jitter, latency, and packet loss. We'll show some of those detailed stats here in a second. It allows the customer to give a high level rolled up view of what's happening in the network, any issues that they should be concerned with, and anything that they should drill down into. We'll drill down into the site by site level view here in a moment after we finish the high level overview. Last item on this page is a breakout of specifically for this customer because they have an LTE service and the active sites with LTE incidents. As we saw above, this particular example customer has a lot of LTE issues that they want a view to be able to drill in and quickly solve LTE issues out in the field, particularly for sites that may be rural, might need a different type of service. If the LTE service isn't working, they can work with us and they can work with their customer success and TSM team to identify, is this service appropriate for this location based on the network telemetry that we're getting? Are we seeing too many faults in an area where we need to consider a different level of service or potentially a different service type to help remediate constant faults? Good example of that is you see customer site K2, 320 alerts within the last week is pretty significant. Allows us and the customer to drive conversations about significantly better network performance at a different level of service for sites that are affected. Moving on to continue to look at high level health of the network from an SD-WAN perspective. We'll look at this page here as a quick overview of things going on in the network. This provides an overview across the network of how the customer's hubs and gateways are behaving from an SD-WAN perspective, number of unexpected reboots throughout the network. If there are a large spike in unexpected reboots, that's something that we want to be careful of, as well as, again, the QoE trend over the course of the network. This helps us, together with the customer, help start managing capacity of the network. If we see a significant number of routes flowing through one data center or one gateway, we want to make sure that we're balancing the network appropriately, such that the customer gets really good performance at scale and we're not overloading given parts of the network. Once we move into transport, we can start looking at transport breakdown across the entire network. So high level, looking at trends over time for primary link issues and given spikes like we see here. On any one of these pages, the customer can drill down by a couple different filters. So they can drill down by profile, they can drill down by location criticality, or they can drill down by carrier. So they can go through and continue to filter all of these dashboards by timeframes and by location metrics that matter to them. From there, they can start looking at transport breakdown across the entire network. So for all the carriers in our network, we can look at, for example, our most popular carriers, Comcast, Spectrum, look at the number of unstable links, disconnected links. Again, we'll highlight that using this view, we can also see that Verizon wireless issue where we have a significant amount of sites. Almost all of these 1,500 sites are on Verizon wireless. We can see a significant number of disconnected and unstable links for Verizon wireless. A lot of tickets open for Verizon wireless, completely outsized by the number of links that are in the system. So when we think about using this information to drive both better operational efficiency and higher network quality, we think about comparing these multiple data points of what are we doing from an LTE and wireless utilization standpoint? What are we doing from a broadband utilization standpoint, DIA, fiber, et cetera? Breaking those down and comparing them to operational metrics so we know what's driving the most effort and what's driving the most fault and what's driving the best quality of experience in our network. Similarly, we can start breaking down bandwidth utilization and start breaking that down by region and site. One more high-level view from an edge analytics standpoint. This is very similar to what we looked at on the front page of looking at alert volume by site and by incident. Here we focus on two different things that are a little bit different. One is looking at top reoccurring alerts. So looking at given sites where again, we have a lot of chronic issues at a given site, where represents typically a lot of flapping links, going in and drilling down into those and saying, again, is this the right service level? Is this the right technology? We're seeing a lot of noise in the network here. Now, because of the AIOps platform that underlies this, I want to call attention back to the top of the page here, where we're saying that we're compressing a significant amount of these alerts. Well, that 500 alerts for a given site down here may have only caused one incident. So we're keeping our operational volume pretty low. But what we can tell is even though our operational volume is low, we're not seeing a significant amount of rework at that site. probably what we're seeing is some degraded impact on the customer's network. We're experiencing increased risk because this is a backup link, and we're going to want to work together to manage that. Again, it's looking at this from multiple facets, from an alert perspective, from an operational incident perspective, and again, we'll drill into the telemetry as well. Last thing we'll note here, call back to a little bit earlier when we talk about monitoring sources. You can see the breakdown of monitoring alerts by different sources. Webhook API, we get very few primary alerts via SNMP for this example customer. We tend to rely on it only as a backup in favor of these more modern protocols. So this is indicating that we're pulling data from multiple different sources. We're creating a lot of alerts. We're seeing a lot of things in the network, but we're compressing that down so that it's easy to operate and it's easy to see what's going on behind the scenes. A couple more items from a high-level network management perspective, and then we'll drill down into an individual location. From a network management perspective, as we look at breaking down incidents by location, breaking down incidents and changes, really giving an ITSM overview, we can start to see incidents by type. Again, really hammering home that for this example customer, we have a lot of access issues, and a lot of it is driven by Verizon Wireless. We have a couple chronic sites that are driving most of the volume within the network. So using this dashboard to go drill down on what is our biggest area of opportunity from an operational perspective. Again, looking at open changes, looking at open incidents, this view will get us very similar to what we saw earlier, but from a pure incident standpoint, allowing the customer to filter and sort through different statuses, different locations. So they could status by anything that's on hold or has comments added, and then start looking and searching through this filtered list, and then can download and export if they need to. These incidents also, if the customer is a ServiceNow customer, we use ServiceNow behind the scenes. We e-bond all of these incidents directly to the customer in their system, so that they have them both in their system as well as available here from a file from a high-level viewpoint. The goal being that we can interact with our NOC to the customer's help desk at an extremely low level, make sure that they're getting really good actionable data moving back and forth in real time. And then we can step back from an overall management perspective and use this portal to look at incidents across the network, look at how it relates to the network telemetry that we're seeing, and look how it relates to the operations that we're performing. Just a couple other KPIs down here showing tickets awaiting response and then tickets that not have been updated in a while. Last two things on this before we dive into individual incident or individual locations. Field service dispatch. So we have field services dispatches broken down by repair and by service activation. Customer can sort through this at a given time and find out what's happening from an operational perspective, from a service delivery perspective, and repair perspective. And then finally, looking at outage information, you can filter by a longer time period to see that, hey, if there are any outages in the network, what was the duration, how was that resolved, what's the current status. Quick filter of all of the locations in the network. This is just a very quick filter for locations that are open. We're going to grab a specific location that has some open incidents. You see there's an open incident. Really good example of compression here of in the last day for this example location. We've had 80 given alerts for this customer location. You can see that it's related to a single incident that is in progress. It's related to access. And as we go down, we can look at the device names down here and really see that this device is driving most of the issues for this site. So as we look at the devices that are currently at the site, looking across of those, if we look at the fact that this device is driving most of the issues, we know that that's a very targeted look at the site. There's nothing else going on there. We have a lot of alerts for this site, but we've targeted it specifically to that network service, and we can triage that specifically without having to worry about the rest of the services at the site. Further drill down on a site-by-site basis of ISP connections. So we'll look at this example site again as a primary broadband, secondary wireless. So you can see that Spectrum Business is our primary, Verizon Wireless is our secondary. On each of these, we can have an overview of utilization and bandwidth, but also looking at some of the lower level network metrics that we use to measure quality, latency, jitter, packet loss. All of those can be remediated to a certain degree by SD-WAN. We measure them here and we alert on them where appropriate, and we can look at those over a given time frame as well. Similarly, from a wireless perspective, you'll also see utilization over here. Again, you can see because it's a backup link, it's pulling in, and you can see maybe some of these issues are caused by we had some poor signal quality. We'll go over here and look at that in a second. We had a significant bandwidth loss. Utilization spiked up probably around the same time that we had those 80 alerts that came in. So you can see that very, very quickly we're able to correlate poor network performance on a link with a bunch of alerts that have come in and a single incident that the NOC is working. If we look specifically at our wireless WAN stats, we can see over time, we can see utilization, overall throughput, signal strength, and signal quality. Looks like we actually didn't have a significant spike in signal quality or signal strength. That's good. Sometimes we see things like they knocked the LTE router antenna off the wall, things like that. So you could use this to correlate any changes in signal quality and quality strength. Any changes in signal quality and signal strength could correlate to alerts that we're seeing in the network. This one looks pretty flat over time. We can zoom out and see if there have been any changes here, but looks like it's pretty stable. You can see over time there's been a couple drops indicative of an issue that would have happened back in the day. And then you can see for this site the utilization over time. So even though we're seeing pretty poor performance from an alert perspective, we're actually not seeing fairly high utilization from an overall data transfer perspective on LTE. It's a good thing. It means that we're not having to worry about significant charges and significant traffic going over this link. We can then prioritize that appropriately and say, well, we have a lot of alerts for this. We have an incident open for it. Signal quality and signal strength looks good. The primary link looks stable, as we saw on the other page. Let's deprioritize this and let's continue to work it at a pace that's appropriate, and let's spend time on critical issues with the network. The ability to see all of this side by side in a single unified observability framework allows us to make those decisions on demand using both our AIOps platform and the tools that our NOC has available to us. But without this, they're going to have to correlate data from 3 or 4 or 5 different platforms, and they're going to have to make these decisions based on manual judgment. Last item to look at here from an SD-WAN perspective, something that we looked at earlier, again, looking at QoE, so we can see some drops in QoE correlated with probably some issues in the primary link previous time. Looks like it's fairly stable in the short term, but we can look at this edge is connected both to a gateway and to a hub. You can see a couple different paths connected both ways. You can see the individual scores on those for each transport type. So you can see that via the gateway out to the hub, we have a pretty high path QoE. We start to see degradation once it goes out to the hub. We see pretty poor video and voice score all the way through the hub. Indicates to us that backhauling traffic out through a data center for this site, probably not a good idea if we're doing that. We would prefer to use a cloud security service that sits right off the gateway to get much better performance there. So this can inform not only what's happening on the current performance level, but we can roll this up into overall network recommendations. Again, good example of that is if you choose to co-locate your cloud security at your data center, kind of a legacy security monitoring practice, you're going to get really, really poor performance all the way back to that data center. We suggest you use our cloud overlays, our SD-WAN overlays, into a cloud security service where you get really, really high quality of experience, very, very good network metrics of latency, jitter, and packet loss. Your network performance is going to be a lot better if you use our recommended reference design versus if you go all the way to this hub. We can measure that path and tell you what it looks like in real time. Last item to note on the site as a whole, and we'll pause after that for any open questions, but last item to note on the site as a whole is a feedback mechanism that we expose to all customers. All customers have a single sign-on authentication to this portal that allows them also to get to the underlying network management portals where necessary. They can also go in here and give feedback to us on the experience, rate the site, and give feedback on given areas as possible. We get really, really good feedback from the customers and really good interaction from a customer. It allows us to gather feedback and continue improving the product at scale versus having to go out and survey customers on a regular basis. We interact a lot with via our technical service managers and our customer service managers with our top tiers of customers. We understand them. But using this automated feedback mechanism and the analytics that we have on the site, we can really deliver a better network management experience at scale. And we're not just at the whims of what the biggest customers tell us.